Hello students, welcome to my YouTube channel. In today's session, we are going to learn about sampling techniques in data preprocessing. Sampling is a commonly used approach for selecting subset of data set for analysis purpose. Here, the subset of data that we have considered will be represented as a sample. For example, consider the data set given, which is having n objects in it. Among these n objects, I'll be selecting few of the objects and making it as a separate set called as sample. Sampling is actually a statistical approach, which means it is used both by statistician as well as the data miner. Statistician uses sampling for two purposes, that is for the initial investigation as well as at the end to perform some analysis. Whereas in case of data miners, for a data miner, processing of the entire dataset is a time consuming and a tedious job, and hence he considers sampling so that his job becomes easier. Key principle with respect to any sampling technique is the samples that we found must be very representative. When I say representative, it means that the subset of the data what we have considered should possess same property as that of the entire data set. Let us consider an example to understand what a representative sample means. Consider the data set given. For this data set, say mean of the data set is a property of interest. First, what we have to do is we have to calculate the mean of the given data set, which is already done here. Mean of the given data set is 10.86. Now, our aim is to find sample out of the given data set such that the sample is representative. In this case, representative means mean of the samples that we have found must be either equal to or closer to the actual mean given. Say, I will consider my first sample, which is 7, 12, 13. I will calculate mean for this. Mean of this sample taken is 10.67, which is slightly closer to the actual mean. Now, say I have found another sample, which is 2, 15, 16. I will calculate mean for this. The mean of this sample taken is 11, which again is slightly closer to the actual mean. Well, now I'll consider one more sample, which is 11, 13, 15. I'll calculate mean for this. Mean of this third sample that we have considered is 13, which is slightly more than the other two samples. Hence, from this observation, I can come to a conclusion that these two means and its respective sample is a representative sample. In actual, representativeness of various samples are different. So now let us move on and see what are the different sampling techniques that we have. The sampling techniques that we are going to learn in this session includes simple random sampling, stratified sampling, and progressive sampling. First, we will consider simple random sampling. As the name itself indicates, this sampling technique is the simplest of all other sampling techniques. In this case of sampling, equal opportunity will be given for all the items in the dataset to be selected as a sample. We do have variations of this sampling technique. We have two variations. First one is sampling without replacement, and the second one is sampling with replacement. Now let us first consider sampling without replacement. So here also, as the name itself indicates, once the item is considered as a sample, then for identification of further samples, these items cannot be considered. That is what is sampling without replacement. So sampling without replacement means that once a particular data object is selected as a sample, To find the new sample, these data objects will not be considered. For example, consider the data objects given. In case of sampling, data objects are also called as populations. Since this is a random sampling, what we do is we will be assigning numbers to each of the data objects that is present, like 1, 2, 3, 4 and so on till the last data object, which is equal to 30, which means here our population consists of 30 objects. Now what we do is, as the name indicates, we are going to randomly select few data objects out of these 30 objects present. Selection of data objects also depends upon the size of the sample that we require. Suppose, for example, in this case, say consider we require a sample of size 6. Then it means that I have to select in random 6 data objects out of the 30 objects present here. Say consider I'll select this data object, second, and this third data object, fourth data object, fifth data object and sixth data object. I have now randomly selected 6 data objects and these data objects are now considered to be as sample. So this is what is actually random sampling means. In case of random sampling, randomly we are going to select data objects equal to the sample size. In this example, since the sample size is 6, we have selected 6 data objects in random. Now, as the name indicates, it is sampling without replacement. That means to find a new sample, these data objects which is already selected will not be considered. That is, after finding the first sample, which means after removing those 6 data objects, the new data set for us looks like this, which consisting of only 24 objects. Next, we have sampling with replacement. In this case, we can tell that each item has equal opportunity to be considered as a sample again and again. Say we have same data set considered as an example. Also, as told earlier, since this is random sampling, first we are going to assign numbers to the data objects. So 1, 2, 3, 4 and so on till 30, which means again here we have 30 data objects. As done in the previous case, I am going to randomly select 6 data objects as my sample size is equals to 6. If the sample size is greater than 6, then I'll be randomly choosing data objects from the given population. Now I'm going to randomly select 6 data objects which will be considered as samples. Now, since this is a sampling with replacement, if I want to find a new sample, then my data set will look as it is like the original data set, because here the sampling technique or the variation of the sampling that we have considered is sampling with replacement, which means data objects that is selected as samples is replaced back to the original data set, so that equal opportunity is given to all the data objects to get selected as. In case of random sampling, there is a disadvantage. So what is the disadvantages? Since here randomly we are going to select the data objects, the sample that we have found or the sample that we have obtained might not be representative. When I say it is not representative, it means that the sample that we have found may not possess all the properties of that particular population or the original population. So in order to overcome this, we have one more sampling technique called as stratified sampling. So next, let us see what actually stratified sampling is. Stratified sampling is a sampling which begins with a pre-specified group of objects where each group is called as strata. Here, as I told earlier, the group size may vary, but the sample size will be mentioned by the data miners. So selection of objects for the sample will be preferably be the same number of objects from each group or each strata. Which means in case of stratified sampling, first we are going to divide the data population into several groups called as strata. Now let us see an example and understand how this is done. So consider the data population which is having again 30 data objects, the same population that we have considered in the previous case. So as told, now we have to divide this 30 objects into several groups. As we can see in this data object, we have male, we have female, and we have a child. So let us divide this data set into three groups. The first group or the first strata will consist of only males, and the second strata will consist of only females, and the third strata will consist of child. So this is how stratified sampling begins. So when we classify the objects into several groups, we call these groups as strata, and the process is said to be a stratification. In the second step of this process, we are going to consider the strata, and from these strata, we are going to select objects to form the samples. As we know that we have to select equal number of objects from each strata. Say consider the sample size required for us is 6, then in that case from each of these strata I have to select 2 data objects. That is, from this strata of men's I'll be selecting 2 men's, and this strata of females I'll be selecting 2 females, and this strata of childs I'll be selecting 2 child to form a sample of size 6. So this process of identifying the sample is said to be as stratified sampling. Now the next question that comes to our mind is, in both these cases we have selected the sample size as 6. But in actual, how do we select sample of a particular size? So let us see an example for that. Is there any issue with respect to the size of the sample? If so, how can that be overcome? Now, the next question is, what should be the sample size? Once the sampling technique is identified, it is important for us to select a sample of suitable size, because as the size of the sample increases, we can tell that the probability of it being representative also increases. As similarly, if the size of the sample is less, which means the probability of getting it to be representative is also very less. So to understand this, let us consider an example. Take this data set which has some pattern of sinusoidal wave as well as square wave, and this pattern is made up of 8,000 points in total. Say now from this 8,000 points I am going to take two samples, one of 2,000 points and the other of 500 points. Let us see what is the difference that we are going to get in these two samples and which sample will be the better one. Now, when I consider a sample of size 2000 points, my data set will look like this, wherein I will be able to identify and make out this pattern similar to that in the original data set. That is, most of the structure of this data set is present in the sample that we have identified. Now say consider using the 500 points of the data set, the pattern that we get or the sample that we get is like this, in which we are hardly able to identify the structure present in the original data set. That is, much of the structure is missing. From this we can understand that as the sample size increases, it will be more closer to be getting selected as a representative one. So out of these two samples that we have found, I can tell that sample which is made up of 2000 points is much similar or closer to the original data set. So which means I can confirm that as the sample size increases, it has a greater probability of getting selected as a representative sample. In case if we don't know the size of the sample that we require, then in such cases, instead of simple random sampling and stratified sampling, we can make use of progressive sampling. So now let us try and understand what actually progressive sampling is and how is it working. Progressive sampling. This kind of sampling is used when we are not sure of the sample size that we are going to consider. This is also referred to as an adaptive sampling. So in this case of sampling, we begin sampling with a sample of smaller size, and as the process moves forward, we are going to increase the sample size. So till when are we going to increase the sample size? Until we get a sample of the suitable size. So how do we get to know that? We'll see and try to understand it using an example. Progressive sampling is mainly used for predictive modeling of data mining tasks. Consider we have a predictive model like this. So as told, we begin modeling or predicting using sample of smaller size. So here input given to this model will be sample size, and then the output will be accuracy. So what we are going to check here is we are going to start with a certain sample size and we are going to measure the accuracy. So we keep on increasing the sample size and compare the accuracy of each sample sizes. When we see that there is no much increase in the accuracy level, then at that point we are going to stop and consider sample with that particular size. Suppose consider I'll begin with a sample of size 3 and I'll get an accuracy of about 20%. Now since this is a very low accuracy, what I'm going to do is I'm going to increase my sample size. Say I will increase my sample size to 5, which means there is a 2 unit of increase in the sample size, and I'll check the accuracy. And accuracy level is increased to about 40%, which means I can see a 20% increase in the accuracy level for just a 2 unit increase in the sample size. So with this observation, what I do is I try to increase again the sample size by 2 units. That is, this time I am going to increase my sample size to 7 and check the accuracy. So accuracy was found to be 60%, which means again I have a 20% hike in the accuracy that we have got. So with this observation, I now will increase the sample size by another 2 units, that is I'll take it to 9 and check the accuracy level. So accuracy in this case is 70. Even though the accuracy is increased, but there is no much increase as compared to the previous 2 cases. Previously, for the first 3 sample size, I have got a 20% increase, whereas here I have got only 10% increase, which means from this observation I can understand that now if I keep on increasing my sample size, I may not find much increase in the accuracy level. So keeping this observation in mind, what I do now is I just increase the sample size by 1 unit and check what is the increase in the accuracy level. The accuracy is found to be 70.2, that is just 0.2% increase is what is found. So now I'll just give another try to increase the sample size and make it to 11 and check what is the accuracy level. So when I see the accuracy, it is just 70.3, which is a 0.1 increase to the previous case. So from this observation, I can come to a conclusion that if I'm trying to increase the sample size, I may not find much increase in the accuracy level. So what I do is I'll just stop increasing the sample size and consider a sample size of 10 or a sample size of 11 for my further analysis. So this is what is a progressive sampling is. We have begun with a sample size which is very smaller. We have continuously or increased the sample size until we get a sample of suitable size. For in this example, we have considered accuracy as a measurement scale to identify the sample size. So this is about your progressive sampling. Thank you students for listening to the lecture. Kindly subscribe my channel. My next video will be on proximity measure. Thank you.